I want to say, like everyone else has said, how honoured I am to be included here. I think Eric and I had sort of bumped into each other around the conference circuits in Africa for a number of years, but I didn't really get to know him well until about 9 or 10 years ago. We were asked to do a review together of a postgraduate teaching program at a South African university, and I had the pleasure of an intensive week of breakfast, lunch and dinner and all the times in between with Eric, and I think we got on well, and we were both pleasantly surprised about how much we had in common and how we thought about things and so on. And it was a wonderful experience. So I was really pleased to be asked by Eric to come and present here. Yesterday, Stephen and David said that when they were asked, they thought, well, Eric merits something original. They weren't going to present something that they had already been worked on, and they started on a new paper. I've gone a little bit further than that. I thought he definitely merited something new. So I tried to do something in an area, not only work I hadn't done before, but in an area I hadn't worked on before. It hasn't worked out very well. It's not a good idea. And for those of you who came because of the South Africa mention in the program thing, you'll be disappointed to see it's kind of disappeared from here. Although I will talk a little bit about South Africa. I think that apart from wanting to recognize a particular contribution, and I have to say I'm not a poverty specialist, I'm not talking about poverty, I'm talking about something else Eric did. And I wanted to actually honor something else that a lot of people mentioned about Eric, his role as a mentor and as a stimulator of others. It's interesting that the paper most of you are familiar with Eric, the FGT paper. Eric was working with his students, and the paper that I'm going to be focusing on was also with a student, Jacques Defournet. I took the opportunity of writing to Jacques and asking him how come he came to write a paper published in the Economic Journal with Eric, and got a lovely letter back from him. And if I can just quote from towards the end, he explained how he was here from Belgium on a scholarship doing an MPA and happened to be taking Eric's class on SAMs and SAM modeling. And he said, at the end of it, he said, I remain extremely grateful to Eric for having paid such attention to the works of a young Belgian MPA student. It's a shame we did not have any further contact, but please tell him or write him how happy and proud I remain for having produced such a paper with him. So I pass on Jacques' things. Jacques is now a professor in Belgium. I think he was co-opted by one of your colleagues here, Jaroslav Vanek, into working on labor-managed firms, and he's published an enormous amount of papers and highly respected in that area. Now, it's my misfortune never to have been Eric's student, and nor to have had to present a proposal to him at an AERC meeting. So, by way of an excuse, what I want to do today is in the way of a proposal. Some ideas that I've been thinking about, that I've tried to implement, haven't turned out right, and I want to present them to Eric. The rest of you can listen if you want. So it's interesting, if you look at Eric in 1984, and not trying to conjure up notions of Big Brother, although in a decent sense, when someone my age could think of Eric as a big brother caring for him. But it's interesting that the FGT paper was published in 1984, and the paper that I want to talk about, the structural path analysis paper, was also published in 1984. I put down some other papers that I found that Eric did in 1984. I'm sure there were some, there are probably some I missed, but just to have produced one of those papers at any time would be a great achievement. And for the two to come out simultaneously in top journals, I think is really interesting. For me, what's interesting is why is the one paper, FGT, I mean, to have a concept not only named after you, but given a nickname after you, the acronym is you, is amazing peer recognition. The structural path analysis, in a way, has had much less, is less widely known. Looking at Google, Google Scholar, I think by yesterday there were just over 4,000 citations to the FGT paper. 354, which is no mean number if you look at Google things. I think many of us would love to have papers with that many citations. But it's interesting the difference between the two. My initial thought, I did some analysis of this, my initial thought too was what I've seen about structural path analysis was I thought it had been fairly dormant for a long time, and recently I've seen many more papers coming out. And so I actually did some analysis of Google Scholar and broke it down into periods. The profile is exactly the same as, of citations, is exactly the same as the FGT paper. So it's not that it's suddenly taken off. But nonetheless, why is it less well known? Well, obviously, fewer economists like to play with matrices and invert linear models and do things like that. Many more work on poverty. And also the poverty paper appeals to something which is a much more direct, more obviously policy-oriented, concerned with the central policy issue. I want to kind of explore that there's a little bit more to its lack of, or its lower renown than the FGT paper. To do this, what I plan to do is to, just as a quick thing, go into social accounting matrix, just in case there are people here who are not terribly sure. I kind of feel bad about doing that. It's, with Eric here, this is almost the center of the universe of SAMs. One imagines everyone at Cornell should know what a SAM is, regardless of their field. But I'm going to go through it anyway. And then I'll show very briefly the notion of structural path analysis, as Eric talked about. And I'm going to then try and explain, I've got to get this right, what I was thinking about when I started doing this paper. Late last night, I thought slightly differently. Not what I was thinking about, but what was I thinking about is much more trying to take us on. And then to just go through some possible developments, which I think would be interesting to take it forward. A stylized social accounting matrix. Basically, we put into a matrix all of the flows that we can get in a model of the economy. All of the cover all of the transactions, payments made down the columns to the various accounts in the rows. And basically, this is one way in which people put it out, but there are many other versions. But we could have, for example, activities and commodities. Often that distinction is not made, and I'll come back to that. Factors of production broken down by different labor skills, if that's what we want, or different types of labor, and so on. Then institutions, households, firms, governments, taxation. We put in an accumulation account for collecting savings and investment, and the rest of the world account. So we can depict the whole economy, and basically we're depicting, we can show you how the circular flow of income. It's really a picture of the economy over a year. And we could, what we can do is we can split it's not arbitrary, but we can do it in different ways. We could split, assume some accounts are exogenous and others endogenous. So everything in the top left-hand quadrant, we could say these are endogenous accounts, and everything off to the right, we could say these are exogenous. And then we can play around. We can convert these into expenditure shares, divide every entry in the column by the column total, and we get a matrix of sort of unit values that we can play with. Once we've done that, and I should point out this highly stylized, the SAMs that the countries now in South Africa, we work in a SAM which has got 14 different household types, and I forget now, 110 different commodities and 64 different activities, a whole range of taxes and this sort of thing coming. But basically what we do, what the tradition with the SAM, and when Eric was doing the paper, contributing in part to this, the standard thing is to do SAM multipliers. We can use some matrix algebra on the SAM to set up a model and to basically solve it, to show how the endogenous values depend upon exogenous values. We can do some matrix algebra and get a multiplier model out. The assumptions that we normally make are some assumptions of linearity and proportionality things, allow us to do this with changes in those variables too. So we can then say a change in the exports of one product, what is that impact going to be on all the outputs of the rest of the economy, and on, if they're endogenous, household incomes, etc., etc. And basically what we're doing, taking the ideas from input-output analysis and Leonto, if we're trying to get not only the direct effects, I am an exporter of coal and the exports go up, obviously I'm going to produce more coal, but also the indirect effects. I'm going to be buying more explosives, the chemical industry is going to be producing more, and we get a whole circular multiplier effect rippling through the economy. And basically that's what we're trying to measure here. Now, once we get these multipliers, the thing slightly before Eric in 1979, Pyatt and Round did some various decompositions. And sorry, I'm jumping at a slide here. Basically, what these multipliers are, it's a comparative static tool. It's something where we can do before and after. There's no time in this model. We're saying if we were able to raise an exogenous variable and let it work through the whole economy, this is where we would end up on a number of very basic assumptions. We can play with all sorts of ways of making this more sophisticated. For example, we can, instead of taking average expenditure shares, we can play around with marginal expenditure shares, which gets rid of some of the proportionality assumption or reduces it somewhat. We can constrain sectors. We can say what happens if some sector is a bottleneck, is not able to expand its production to meet demand. What does that do to the economy? We can turn the whole model on its head and make it a price model, work out sort of cost push inflation type things. It's a very simple but powerful tool for economy-wide thinking. In my experience, and I spend a lot of time building CGE models, which are seen as going beyond this and allowing for much more substitution and more sophisticated stuff. But in my experience, for many policymakers, simplicity is very important. When you're advising ministers, you want something which you can show very simply. And often the CGE models that we build, the interactions are so complicated that it's quite difficult to get the story across. Whereas here we can do things very, very simply. In my experience too, this economy-wide way of thinking is very instructive for policymakers. I do some teaching within the Treasury in South Africa, and have been doing for a number of years. And a number of my good friends say, what's the point of what you're doing? What's the point of these CG models and these SAM multiplier models that we play with? And I say, you know, they say you're making up the numbers, which often we have to because they don't exist. It's very heroic assumptions and so on. So what's the point of it? And I say, just talk to the people I've been teaching about their understanding of how the economy works. They've been having to think that this affects that, which has a knock-on effect to this, rather than thinking in their silos, which many of us tend to do, of just focusing on our area of interest. So it's a very good tool, I think. And Gary mentioned in his talk about Eric's work on consistency analysis. In a way, this is forcing us to think about being consistent and how consistency requirements work. And I think that's powerful, even if the numbers themselves aren't as accurate as they might be. Well, what people tended to do, and as I said, for Python round, they did some multiplier decompositions. We can break this down into different components, divide up the matrix into various endogenous things, the exogenous, the interactions between them, and we can break down this. In the structural path analysis paper, Jacques and Eric go through that sort of multiplier decomposition. I think of structural path analysis is basically a decomposition analysis. It's saying, how can we go beyond this multiplier to understand something about what's happening inside it, rather than just coming up with a big number, or often a small number. So I'm going to, here, plagiarism is the greatest form of flattery. I'm going to take a diagram from the original paper, which is basically the idea that behind structural path analysis. Eric said, let's look at the paths through which influences work in this multiplier model. So we can talk about, apologize for how small the writing is, but we can talk about an origin and a destination. Say there's some shock, there's a rise in demand for something, and we're interested in what does a rise in the demand for coal do to the agricultural sector. And we can trace it. Obviously, there's a direct effect. But there are also various paths we can work. There's some indirect effects. This is terribly small. I apologize for that. We can say that our origin sector affects some other sector. It buys inputs from that other sector X, which buys something from Y, which buys something from our destination sector. And we can trace through what Eric calls an elementary path. We can make this more complicated because there may be some interactions between Y and X on the way. So there's a little multiply expansion going around, a little circuit of flow of things that's going to go round and round between X and Y and add to the impact along the elementary path. And there'll be some other paths. There may be just some direct linkages, or to complete the diagram, Eric said, you know, there may be other things, all sorts of ranges of paths that go. There may be sectors which have loops that are buying from themselves, and that creates a multiplier. So, now, in a way, this is early network analysis. You know, and thinking about, unfortunately, he's had to leave, but Jim's paper this morning with his network of tourists. This is the sort of diagram that he's thinking about, not in an economy-wide approach, but it is network analysis. What Jacques and Eric did was they were able to say, let's take the stuff from our social accounting matrices, take the coefficients of purchases by one sector from another sector, and we can figure out, we can attach some numbers. These you can't see, probably fortunately, but we can take some coefficient. What's the per unit purchase of our sector in which the shock originates from the destination sector? Or we can go along the elementary path, and we get a whole lot of these coefficients, which if we multiply up is going to show us along that path what the effect is going to be. Or we can add in a whole lot of things, all data constructed from our social accounting matrix and the expenditure shares that we put in. And basically, that's the idea of structural paths. What structural path analysis was doing was to say, and what Eric said, was we can find different types of influence, direct influences, total influence along a path. We can compare those direct and total influences, and we can get multipliers. How much of the expansion in the economy comes because of the multiplier along a particular path? Now, obviously, we get many paths between an origin and a destination. There are different goods that come in, and we could. The diagram's just showing a 3-arc thing, but you can get many, many more chains of causality going through the thing. And ultimately, if you've got all of the paths, all of the total influences possible, and added them up, you would come back to the multiplier effect that we've calculated. So we've, in a way, decomposed that, what we're going to get out of a multiplier analysis to say these paths matter. It's a very, in a way, very straightforward, although having spent the last few weeks trying to write out a GAMS program to solve it, and that's why I'm not showing you results. I get results, but they don't look reliable, so I'd rather not release them into the wild. But it's a very powerful concept. Now, having looked at this, my question of why don't we get more? Why haven't we had more analysis? Surely this is a powerful thing to see how effects work their way through the economy. Surely that's something we want to do. Jacques and Eric's paper was a pioneering paper, and if you look at the conclusions of it, they actually suggest ways in which it could move forward in 1984. Now, there has been some development, but not as much as one would have anticipated. And to some extent, my feeling is, why does knowing the path matter? When I'm talking to a policymaker, should he behave differently if he knows this effect? We know what the total effect is going to be. We get that from our multiplier. But if we know that the effect works mainly through this path and through some other path, should he behave differently? Should he be intervening in the economy differently? So it's a great descriptive and possibly analytical tool. And I want to just highlight a paper, I think one of the best papers I've read on this, by one of Eric's former students. He's not here at the moment, but Iwani Aziz. Really excellent paper on the impact of the financial crisis in the 1990s and how it leads to social crisis. Using the path to get it. Very interesting. But why does it matter for a policymaker? Well, my unimplemented idea, when Eric asked me, I thought, well, here's a chance for me to do something on structural path analysis. And in South Africa, as elsewhere in Africa, you often get sort of popular talk or policy talk. I hear ministers talking about what we need is structural growth. I think there's a lovely quote from Bob Solow. Structural often appears to be a word used to communicate that one is talking about something deep, but doesn't actually know what it is. It's a lovely quote. It's not true in this case, but I had to put it in there. We know in SAMs and SAM analysis, we know what structure is about. And in fact, if one looks in economics, structure, I would think Hollis Chenery's lifetime was given to analyzing what is structure and why does structure matter. Austrian economists think structure matters, and so on. My idea, though, was in South Africa to draw on some work that I tried doing earlier, some years ago. Jose Antonio Campo has said development is really about shifting resources from dynamic sectors, of shifting resources into dynamic sectors that have strong linkages. We don't just want productivity growth in a sector. We want that sector to be well connected to the economy so that the growth in that sector, the dynamism of that sector, spills over into the whole economy. So some years ago with a colleague, Dirk van Seventer, we tried to construct what we called a measure of systemic dynamism in South Africa. We did a whole lot of time series multiplier analysis and looked at labor productivity issues and then tried to construct an index showing whether we were becoming more dynamic or systemically dynamic. It didn't really work like so many of the great ideas I have. And I thought, when Eric asked me, I thought, well, maybe structural path analysis would allow me to do that. It would help. My idea was to say, if a sector, in most structural path analysis, we think about the origin and the destination and the path between them. But if a sector is an important node in the path and in lots of paths, then wouldn't we expect growth in the economy, since it's all going through that Grand Central Station, as it were? Wouldn't we expect that traffic there to grow a lot and that sector to grow? So can we focus on the nodes rather than the origin and destinations? And can we look at the properties of those nodes? So the notion that I had, which I haven't done, was to say I wanted to look at productivity growth, but actually extending it, thinking about poverty issues. Is it possible to look at sectors and wage income distribution within sectors and then talk about how those sectors are affected by being nodes in important structural paths, and therefore how development, which may be happening with demands for other things going on, how it's going to develop. In South Africa, for example, one of the flagship policies of industrial policy in South Africa since 1994 has been the so-called Motor Industry Development Program, which the proponents of, there are lots of critics of it, but the proponents say there's so many externalities from building your own motor cars, having a motor industry, that this is a good thing to foster. And they put a lot of, not money into it, but they've given a lot of privileges to motor producers and so on. Now, what I wonder is, can one actually measure these kind of externalities, effects, by looking at the paths by which the motor industry is connected to the rest of the economy, and which of these sectors are going to go? And my idea was to compare it over time. I constructed 2 SAMs for South Africa, 1993 and 2010, and to try and see, have these paths changed? Have their importance changed? I've added in red there something stimulated by Jim's paper this morning on the loss of networks. I mean, it's actually an interesting issue about, have these paths diminished over time? Have some of the paths disappeared? And I want to look at those issues. I'm not going to give any results on it. It's not giving you any meat to talk about. It's just the menu, not the actual meal. But let me just say a few final things, because I know, and I want to get Eric's response to some of these issues. One of the problems that I have looking over time is the importance of getting constant price things. Because we're making assumptions, we're trying to extract from value information what the technical coefficients are. We have to make assumptions that relative prices are not changing when we're aggregating things into sectors. And I've seen a number of papers. There's a nice paper by some colleagues comparing South Africa and Vietnam, but doing them in current price terms in both countries, because we're not worrying about time, they argue. But actually, if relative prices are different, in the two countries. You can't tell whether the technical information, the technical coefficients you are extracting from the value data is actually the same, whether they mean the same things even. And so a large part of why I wasted a large part of time, my time trying to do some deflation of it. And it's not a simple exercise deflating. It's not even clear what some of the things mean when you deflate them in a social accounting matrix. It's something to think about. I just wanted to mention here something that worries me, to what I call the dominance of SIC, the dominance of the standard industrial classification. One of the problems, people have been complaining in poverty work about lack of data. So there's sometimes a problem with the conventions around the data that is constructed are such that we get stuck with them. So much of the industrial classification, then, although there's some analytical basis behind them, they're not really analytical. It's around types of products, basically. And often what we would like to be able to do is distinguish between technologies in our paths and so on. And there's some interesting recent work being done in breaking up SAMs according to technology rather than SIC. In the original paper, Jacques and Eric, they collapse activities and products. There's only, every industry produces one product, and fairly standard assumption. In a way, we can do that because we're interested in connections between industries, and the products are really just the carriers of the path. They're not what we're really interested in. But one of the problems that we run into when we make those distinctions, it's very difficult to deal with imports. And one of the questions I would like to ask Eric is whether it's possible to break it down. I tend these days to use supply-use tables which distinguish between these things, products and activities. So farming is different from wheat. Farming is the activity, wheat is the product. It's a much easier way of handling imports. And it worries me that some of the structural path analysis I see, actually the paths include imports, and they should be leaking out of the economy very quickly. And finally, just on time, speaking of time, I'm not sure if I've got time, but okay. Last slide. One of the things, as I said, I see structural path analysis as a decomposition method of multiplied decomposition or SAM decomposition method. Basically, it's a static method. It's comparative static. It's not a dynamic thing. But path carries connotations of movement, of time. We're describing a path, but we think a path is something along which things move. And there's often a temptation to speak of it as if it's time. This path is first this happened, then this happens, then that happens. Whereas actually when we're solving these things, it all happens simultaneously. And I think one of the obvious lines of development is to bring time into this. Now, it's something I tried also, a litany of failed ideas. Some interesting work by Louis de Menard on input-output analysis, trying to introduce time into that at a purely theoretical level. And I thought this would be a great idea to work on in South Africa. And I asked a lot of my industrial organization colleagues and friends and so on, a question: can you tell me, for different sectors and making whatever heroic assumptions you want, how long it takes for a market signal to be received and the output to be delivered in a particular sector? Can we get any information about that? Does that data exist? The only data one I could find was on from business schools on time to market, which was about products being invented and before they got marketed. But the actual time it takes for us to respond to things is very difficult to get empirically. So although there are theoretical ways in which we can introduce time into this, the empirics of it are enormous. So there's some things that I would like to be able to do if Eric will allow me later, if he thinks it's a good idea. Thank you very much.